Hello, my name's Andrew from Andrew's Maths Tutoring, and today we're going to be going through the solutions to the free worksheet that was uploaded for the primes, factors, highest common factor and lowest common multiples video. If you haven't had a go at the worksheet yet, I'll put a link down in the description below, but I'd also recommend checking out the tutorial video that I've made before you try the worksheet. There will also be a link in the description below linking to that video. So the first question asks us to identify all the prime factors of the number 56. So the method that we want to do this, our first step, is to draw a factor tree until we reach a prime number for every branch. Then we want to write out all of our prime factors. Let's go ahead with drawing our factor tree. So we write out the number 56, and we want to break this down into two numbers that we can multiply together to give 56. If we can make one of these a prime number, then that's a good start, but we don't need to overcomplicate this either, and we can just choose the number 2 if our top number is even. So I've chosen 2 and 28 here. 2 is a prime number, so we can stop breaking that down any further, but 28 is not, so we need to break that one down further. So I've chosen 14 and 2. 14 isn't prime, so that needs to be broken down further too. I chose 2 and 7, both of which are prime numbers. To identify all of the prime factors of 56, we need to look at all the numbers that are at the end of the branch in this tree. So these are the numbers 2 and 7. Our next question asked us to express 87 as a product of its prime factors. Our method is very similar to last time, where we need to draw out a factor tree until we reach a prime number. Then we need to write out the product of all the ends of the branches. So let's give this a go. We start with the number 87, and we want to break it down. We can't choose the number 2 here, as 87 divided by 2 won't give us a whole number. Let's try the next number up. I'm going to choose 3, and it turns out that 87 divided by 3 is 29. Conveniently, both of these are prime numbers, so this question is a lot easier than it looks. As 87 as a product of its prime factors, all we need to do is identify every prime number in our tree and multiply them together. So for this one, it's just 87 equals 3 times 29. The next question asks us to express 162 as a product of its prime factors, but in this time in exponential form. So if we're a bit unsure about what exponential form is, at the moment we can just ignore this and focus on the first part of the question, expressing 162 as a product of its prime factors. First, what we want to do is make our factor tree in the same way that we have for the other questions. So we start with 162. We can break that down into 2 and 81. 2 is a prime number, but 81 isn't. So we can break that down into 3 and 27. 3 is a prime number, but 27 is not. And 27 can be broken down into 9 and 3. 3 is a prime number, but 9 is not. So we need to break that down into 3 and 3. To express 162 as a product of its prime factors, we need to multiply the bottom of every branch together. This involves multiplying numbers 2, 3, 3, 3, and 3 together, and that'll give us 162. So if we write that out, as shown here, what we can do is change it into something called exponential form. And exponential form just means that instead of writing out every number, we write out the first number and write it to a power. So as we only have 1, 2 in our equation, we write it as 2 to the power of 1. As there are 4 3 values that we're timesing together, we write it as 3 to the power of 4. Question 4 asked us to find the highest common factor of the number 60 and 150. Our first step is to make a factor tree until we reach prime numbers at the end of every branch for both numbers now. We then want to identify which prime factors are in common. Once we've done that, we multiply the prime factors together. So let's go ahead at making our factor tree, first for the number 60. So we take the number 60, and we want to break this down. So I've chosen the numbers 2 and 30. You could have chosen 3 and 20. As long as you end up with the same prime numbers and do your divisions correct, it'll work out the same. 30 still needs to be broken down, so I've chosen 15 and 2. 15 can then be broken down further into 3 and 5. So now we have an expression using our tree for the number 60, which is 2 times 3 times 5 times 2. And that's just the bottom of each branch multiplied together. We now want to do the same for the number 150. So we take 150 and we're going to break it down. So I've chosen the numbers 15 and 10 here because dividing by 10 is also another easy route to use when you have larger numbers. We know that 10 can be divided into 5 and 2, and they're both prime numbers. And 15 can also be divided into two prime numbers, which is 3 and 5. Using our tree, we can write out an expression for 150, being 3 times 5 times 5 times 2. So using our factor trees, we came up with these two expressions for the two numbers asked in the question. And our next step was to identify which prime factors are in common between the two numbers. So if we take the expression we have for the number 60, and we go along each number, we can circle which numbers appear in the expression for 60 and the expression for 150. So first we have the number 2, and we see that that appears in the number 150 as well as 60. Next we have the number 3, and that also appears in both. Then we have the number 5. We also have another number 2, but as there is not another number 2 in 150, we can't circle this. And the same applies for the extra 5 in 150. Our final stage was to multiply these prime factors together. But be cautious that you only have to do this for one row of circled numbers. We don't multiply all 6. So in this example, we only multiply together 2 times 3, which gives us 6, and then times that by 5, which gives us 30. Question 5 asked us to find the lowest common multiple of 60 and 150. To find the lowest common multiple, we need to multiply the highest common factor by every remaining prime factor. Well, we just worked out our highest common factor, and that was 30. We need to identify what the remaining prime factors are. So these are circled in red, and these are 2 and 5. These were the only numbers that didn't get circled when we were trying to identify the highest common factor. To work out our lowest common multiple, we take the number 30, which was our highest common factor, and then we multiply it by 2 and 5, which were our two red circles. 2 times 5 is 10, and then we're left with 30 times 10, which is 300. The next question asks us for the highest common factor of 72 and 120. So our method is the same. We're going to make a factor tree until we reach prime numbers at the end of every branch for both numbers. We're then going to identify which prime factors are in common. And then we want to multiply those common prime factors together. So let's do a factor tree for the number 72. We take the number 72, and if we divide it by 2, we also get the number 36. We then need to break down 36 further, and that breaks down into 18 and 2. 18 can be broken down into 2 and 9, and then 9 can be broken down into 3 and 3. Every prime number in this tree, when multiplied together, will give 72. So in this situation, we have 2 times 2 times 2 times 3 times 3. And it doesn't matter what order you write them in, as when multiplying numbers together, you'll always get the same final answer. So now we need to do the same thing for the number 120. We stick the number 120 at the top of our tree and break it down. I've broken 120 into 2 and 60. Two other good numbers to choose would have been 12 and 10. I'm now going to break 60 down into 30 and 2. 30 needs to be broken down into 2 and 15. And 15 can be broken down into 3 and 5. We can then come up with an expression for 120, which is the product of every prime number that's in our tree, and every prime number is the bottom of each branch. So we have 2 times 2 times 3 times 5 times 2. Our next step was to identify the prime factors in common. So I wrote out our expressions that we found for both numbers using our factor trees, and now we want to identify which are in common. If we go across each number, we start with the first 2 in 72. We can see that there is a number 2 in the expression for 120, so we can circle that. Again, we have another 2 in both 72 and 120, so we can circle that. The same applies for the 3 and the final 2. The expression for 72 has another 3 in it. However, because the expression for 120 doesn't have another 3, we cannot circle this. We now need to multiply a row of our prime factors together. So our highest common factor is 2 times 2 times 3 times 2, and this gives us 24. Our next question is finding the lowest common multiple of these two numbers. So to do this, our method was to multiply the highest common factor by every remaining prime factor. So let's circle our remaining prime factors, and they're 3 and 5. We already found that our highest common factor was 24, so what we need to do now is multiply 24 times 3 times 5, and this gives us 360. So let's go over our final tips and tricks. When doing your factor trees, always remember to continue until you've reached a prime number. Remember that when you're finding the highest common factor, you're generally looking for smaller numbers. The highest common factor will always be less than both of the numbers or equal to the smallest number. The lowest common multiple will always be greater than both numbers or equal to the highest number. If you found the tutorial useful and these word solutions useful, please do consider subscribing to this channel. And if you have any questions about what you've seen today, feel free to leave a comment below. And finally, if there's any requests for future topics to cover, also leave a comment below. Thanks very much for watching, and I hope this was useful.